minus 4AC all over 2A.
Excellent job. Give him a hand. Give him a hand.
What? You just said no. That's so...
Say no before.
I'm so...
Remind me, I'll get it in a moment.
Yeah.
Okay, so today we're going to talk about just part of the quadratic formula. The part of the quadratic formula we're going to talk about is b squared minus 4ac.
Uh-oh, Dave.
We're going to talk about b squared minus 4ac. So you will notice where that is located in the quadratic formula. It's what's under the radical. Whoops, underneath the radical. B squared minus 4ac is underneath the square root symbol. This is very helpful because we can tell things about the solutions or about the picture before actually doing a lot of work. If the value of the discriminant is greater than 0, if it is greater than 0, that means it is a positive number. If it is greater than 0, then it is a positive number. If it is greater than 0, then we know that there will be two real solutions. We know graphically if there's two real solutions, then this parabola will pass through the x-axis 2 times. So we can tell all that information by just knowing that b squared minus 4ac is a positive number. If b squared minus 4ac is equal to 0, if it is equal to 0, then there is one real solution. And that means that our graph, the vertex of the parabola will be right on the x-axis. It'll only touch the x-axis once. And third scenario, if b squared minus 4ac is less than 0. Less than 0 means it is a negative number. Then we will have two imaginary numbers for our answer, two imaginary solutions. Graphically, that means there is no x-intercept. You can see the x-axis and this graph does not cross it. If there are two imaginary solutions, what will my answer have in it? I. It will have the I. Yeah. So here's 3 examples we're going to go through together. The first one, x squared minus 6x plus 10 equals 0. We're going to find the discriminant. The formula for the discriminant is, b squared minus 4ac. b squared minus 4ac. Wait, don't you want to finish it? Okay. All right, so we're going to do b squared, which is 36. Then we're going to minus 4 times a is 1 times c is 10. So we get 36 minus 40, which is, I heard it, negative 4.
No, we don't include the square root.
Correct. For the discriminant, it's only b squared minus 4ac. So what does negative 4 tell us? We go to our chart.
That it's one.
It is less than 0, so there are two imaginary solutions. Question B. X squared minus 6x plus 9. So we're going to do b squared minus 4ac. We're going to do 36 minus 4 times 1 times 9. 36 minus 36 is 0. Discriminant is 0. So one real solution. It means when you do your quadratic formula, you only get one answer. Question C. X squared minus 6x plus 8. We're going to do b squared minus 4ac. So 36 minus 4 times 1 times 8. So it's 36 minus 32 is 4. Two real solutions.
Are you recording?
I hope so. Alright, when you look at the next page, there is a typo at number 8. So before you do anything, everybody go fix number 8. It should say 1/2. 1/2 x squared. Yeah. That would be another teacher typed it up on a Mac and then it didn't transfer over to the not Mac software. That's what happened. But that it should say 1/2 right there. Okay. I'm now going to pause the video so that you can find the discriminant and say how many solutions for each question, and then we'll go over it together. All right, help me out. The first one, the discriminant was 0, which means one real solution. Second one, number 8, discriminant 3. And the answer is 3. By the way, for the work for that one, because I did have a lot of people get that one wrong, the work would be b squared would be 1 squared minus 4 times 1/2 times -1. So that would, if I'm doing that by hand, that would be 1 minus -2, which is 1 plus 2. Which is 3. And that gives me 2 real solutions. If you are somebody who's looking for an abbreviation for solutions, like it's so long to write that word out, it would be SOL apostrophe N or apostrophe NS if you're looking for an abbreviation that is accepted for solutions.
RS.
Next one, you had to make that equal to 0 first, so you do 5x squared minus 8x plus 13 equals 0. Then we do b squared minus 4ac, so we get 64 minus parentheses 4 times 5 times 1.
Which is
13, not 1. 13.
Oh, that's a 13. Sorry. 13. I can't read my own handwriting. All right, and then you get what? -1, is that the -196? So 2 imaginary solutions. Then we've got, then we got number 10, that has to equal 0, so you do 7x squared minus 3x minus 6 equals 0. Then you do your formula 9 minus parenthesis 4 times 7 times -6. And you get positive 177 after you add them together for your discriminant. So 2 real solutions. Again, the biggest mistake I see is you're not putting in the parentheses, and so you got your order of operations wrong. Probably forgot a negative somewhere in there. I would encourage you to do it the way that I model it in class so you make less mistakes. This one, you have to make it equal to 0. 4x squared plus 6x plus 9 equals 0. And we do 36 minus 4 times 4 times 9. We get -108 for our discriminant. So 2 imaginary solutions. Sorry, I didn't have room. And then the last one, you have to make it equal 0. You have to make it equal to 0, so you can either move the stuff to the right, or you can move the stuff to the left. I am going to move the 5x over. Because remember yesterday I told you to keep that positive as much as you can.
What is?
So I'm going to get 5x squared. I'm going to move the 1 over. I'm going to keep that 10x over there, minus 10x. Move the 1 over, I get plus 5. And then we do our discriminant, and you guys end up with 0 for the discriminant. So 1 real. All right. This next example we are not doing. Concept summary. This is really going to be more important for tomorrow's, well, I guess we'll see you on Thursday. Yeah, no, tomorrow for us, right?
Yeah.
Last day. Mess me up every time. All right, so tomorrow, if you look on what's happening tomorrow, we're going to be reviewing tomorrow for a quiz that's happening on Friday. But the quiz is on all of chapter 3 so far, so it's going to combine all of our methods. So these notes, don't get rid of them. These notes are going to be important tomorrow when we combine everything. So we'll come back to that tomorrow. Last thing we're going to look at is real life example. And this has to do with when an object is launched or thrown or dropped. So what I have in front of me, and anybody watching the video, I would apologize to you because you can't see what I'm doing. I guess I could do that, but I'm not going to. What I have in front of me is a marker, and if I just hold that marker out and I just drop it, then I have no velocity. I have 0 velocity. I'm not throwing the marker. Okay, all I did was mic drop it, right? You know what I'm talking about? Okay? That's all I did. So that would be a question that has no velocity. Why is the marker going down?
Gravity.
Because we have gravity. So gravity is already factored into these equations. You see these equations right here.
What about air resistance? We're trying to get this complicated.
Well, that would be not in this particular. We're not getting that complicated. But if you are taking physics next year or your senior year, you are going to come across these kind of questions. These are real life questions. There are many things in life that get thrown or dropped or launched. And we have to calculate, like if you go into the military, they need to calculate exactly where the missile is going to drop. You think if they drop a missile from the ground, or from the air, when it goes to the ground, does it go straight down?
Well, they have computers to calculate all that.
Who programs the computer?
Some smart dude who's already done it.
Somebody who knows how to do physics.
Yeah.
That's what happens. So the computers don't magically work on their own. Like, there has to be somebody doing that. Okay, so anyway, what I'm getting to is this equation is used a lot. The negative 16 part, that has to do with the gravity. That is where your gravity is factored into it. That number is always going to be negative 16 in these equations. And then we have t's. In both equations, there's t's. And in this paragraph, it says that t is the time that the object is in motion. T starts as soon as the pen is dropped or thrown, and then T ends when it stops moving. We also have V sub 0. The sub 0 is not affecting the number at all. It's just saying that this is that particular V. It could be V sub 1, V sub 2. That would be like the second V, the first V. This is the 0 V. It is not like an exponent. So the vertical velocity, that has to do with what I am doing with this marker. So if I'm just simply letting go, there is no velocity. And you would use this first equation. But if I threw the marker up,
Whoa.
there would be velocity, and that would be an upward velocity. And it says it down here, if there's an upward velocity, then the V value is going to be positive. So if there's an upward velocity, the v-value is positive. Watch if this marker could draw in the air. Watch the path that the marker does when I throw this marker up. It makes a parabola. I didn't do that on purpose. I can do it on purpose, but I'm not. I can really do it on purpose. Oh. It does make a parabola every time you throw something up because of gravity. The gravity is going to pull it out slightly, and it's going to make a parabola every time. The same thing is when I throw the marker down, it does the same thing. It makes a parabola. You just can't see it because it's a very short distance. You can tell I threw that down. I didn't just drop it. So if I throw it down, that would be a downward velocity, and that would be negative for our velocity. And if I just did the mic drop, if I just let go, then our velocity would be 0. A couple more things in this problem. H sub 0 is the initial height. So, you know, if I'm holding my marker about this high, straight out from my shoulders, you'd say probably my initial height is about 4 feet. Because I'm not very tall. I'm only just over 5 foot tall. So this would be about 4 feet for my initial height. What would be my height now? It would be 0 because I'm laying on the ground. The other H would be the height after something has happened. So this would be after the time. So H sub 0 is the initial, and then H is just after whatever just occurred. So once you have all that information, we're just going to plug stuff in and solve it. So let's look at the example. A juggler tosses a ball into the air. The ball leaves the juggler's hand at 4 feet above the ground, has initial vertical velocity of 30 feet per second. The juggler catches the ball when it falls back to a height of 3 feet. So we are imagining a juggler. You've seen a juggler before. I can't do it, so it's not going to happen. Tossing a ball into the air, and if I'm tossing a ball, there is velocity because I'm putting force on it. And if I'm tossing the ball into the air, is that going to be a positive velocity or a negative velocity? Positive, because we're throwing it up. Juggler juggles up into the air. And the initial velocity is 30 feet per second. So we're going to write our equation. We're going to always start with negative 16t squared. Then our velocity is going to be positive because it's going up in the air. T. Then we add on h sub 0 from the, I'm just taking this from the formulas on the previous page you guys have on your paper in front of you. H sub 0 is the initial height, 4 feet. Then what goes over here, that's going to be the ending height. So he throws it at 4 feet and he catches it at 3 feet. So could we solve this using any methods the way it is right now? No. Why?
Move 3 over.
Because it's not equal to 0, right. So we're going to move that 3 over, make it equal to 0. Has to equal to 0 before we start. Now this doesn't say you have to solve it a certain way, so this is really up to you. What methods do we have to solve it? Factoring, complete the square, graphing, quadratic, formula. What do you want to use?
Might as well do quadratic.
I don't want to use complete the square. Be up to you guys. Quadratic formula sound good? What we've been practicing? Okay. So you don't have to do this next step, but I definitely said quadratic formula is a lot easier to use if this number is positive. How can I make that number positive? I could move everything to the right, or multiply everything by -1. Your choice. I'm gonna multiply everything by -1. Do something different.
Are you gonna do the full project?
I'm gonna do the full quadratic formula, yeah. As opposed to what? I'm sorry, as opposed to what?
Opposed to the half.
Yeah.
I mean, what do you mean by what we did today? Are you talking about the discriminant? The discriminant just tells us how many solutions there are. But to actually find it and solve it, we need to do the full quadratic formula, yeah. So x equals opposite b plus or minus square root b squared minus parenthesis 4ac all over 2a. I'm going to simplify it just a little bit. And then I'm going to stop and think about it. This is a real life example. Is square root of 964 a number that square roots nicely?
Yeah.
Well, type it in your calculator. Do you know what the square root of 964 is? Does that type in and give you a nice easy answer?
No.
Mm-mm. So let's think about this. What kind of answer am I looking for? This is a real life example. What are they asking me to find?
Not imaginary.
It's not imaginary. That's good. That means there is an answer. What are they asking me to find? It says, how long is the ball in the air? What is that? What are we solving for? In this equation, what am I solving for?
T.
T. T is time. Does it make sense to have a square root of 964 as part of my answer if I'm talking about time?
I did not.
No. Would I tell you that I can run the 50-meter dash, whatever it's called? What's 50 yard? What's what?
40
meters?
yards out.
I don't know. Can I tell you I can run a mile in like square root of 964 minutes? I mean, would you'd be like, what does that even mean? I need to calculate that.
Well,
That is-
You could fake someone out. I can run it this fast. How fast was that?
I don't know. I don't know. That's the
Pretty
thing.
slow. Bob.
Yeah, I don't. It probably would be true then. We're not going to use square root of 964 in our answer. We're going to find the calculated approximate decimal. So we might as well pull out our calculator now. And remember, there are two answers here. One of them is 30 plus square root of 964 all over 32. The other one is 30 minus square root of 964 all over 32. So go ahead and take a moment and type those in your calculator and find out what time it takes this juggler to toss one of these balls or whatever he's tossing. How's the ball? A ball. How close? You know about that third. Think about these are time. Think about that for a second. So you have two answers, but then we're going to think about our answers. Because again, this is a real life example. Alpha, y equals. Y equals. Is that what you're looking for?
Yeah,
That's
yeah,
the
yeah.
fraction?
Yeah, thank you.
All right, Gabe, what'd you get for the first one?
I got 30.
You did not divide by 32. Did you divide by 32 on your calculator?
For nothing.
You must have typed it in wrong on your calculator. I'm coming back to help you. Somebody else. Colin, what'd you get for the first answer?
1.90.
Yeah. You have to
1.92.
sort of say on the top. Here, hit second enter. Now, delete the divide by 32. Hit enter. then divide by 2, or 32. Okay, thank you, Colin. It's approximately 1.9. I just rounded it. Okay, and then Brian, what'd you get for the second one?
-103. Impossible. You can't go backwards.
Right, this is time. So what we're going to do is we're just going to reject this answer because you can't have negative time. That's not going to be our answer. You can't have negative time. So our only answer is 1.9 seconds. That we only rejected it because it's a real life situation. If it wasn't a real life situation, we could have a negative answer. Only because we can't have negative time.
In the perfect scenario, shouldn't that be 0 technically? The answer on the right when you throw the ball? No?
I'll explain in a second. So you guys can grab your computer.
3.4.
3.4, day 2.